Hello everyone, this is the third video of 3.3 hydrocarbons lecture video. In this video, we will talk about the last box there. So hydrocarbons can be represented by empirical formulae, molecular formulae, and structural formulae, including extended, condensed, and skeletal representations. All right. Let's move on. Now, the slide that I would like to go, actually, before we move on to formula stuff, I would like to finish off one of the homologous series that we didn't get to talk about. So, that is alkene. Sorry, I said that again. Alkyne, because it's got Y in it. Y-I, alkyne. All right. Yeah, organic chemistry have got all kinds of issues and problems that you need to be able to solve, and that's what this is one of those things. Alkynes must have the triple bond, so C to C triple bond must be present. Sorry, general formula for any alkynes with one triple bond would be CN H2N take 2. CN H2N take 2. Okay. Alkynes are also unsaturated compounds because of the triple bond. You can put more hydrogens into it to make it into alkane. But yeah, alkynes exist with triple bond. For example, propine. So prop, hopefully you remember or you learned it already. That prop means 3 carbons, and ine with Y and E ending, that shows that there is a triple bond somewhere. So try drawing that using one of the structural formula, and this is a segue to next section where we talk about different ways of showing organic compounds. Now, the one that you see far left corner is called the extended structural formula. So that's one type of a formula that shows the structure. This is a fully extended version because all the bonds are shown, all the hydrogens are shown. It's the most simplest one that you should probably use to practice drawing the formula to start with. Okay. I recommend you to use extended structural formula until you get used to the idea that all the carbons have 4 bonds. Okay? There are 8 carbons in there, so it's, namely it's called octane. There is no double bond or triple bond, so yeah, it needs to be octane. Okay? So 8 carbon with 18 hydrogens. Okay? So it's C8H18. That's the molecular formula. Now, I already used the word molecular formula there. And you can see a molecular formula just above here, molecular formula, and it says C8H18. What the molecular formula shows is just a ratio. It's just a ratio of each atom, each type of atom. Okay? So C, there are 8 of them. H, there are 18 of them. But it doesn't show how they are connected, because structural formula's job is to tell what and how those are connected. Because we'll talk about that when we talk about what's called isomers. With using C8H18, you can make more than one type of structure. Okay, but structural formula should all show one structure. Okay, for example, the one below extended structure, you can find condensed structural formula, which just says CH3, CH2, CH2, blah blah blah, and at the end you have another CH3. That is the condensed version of the the extended structural formula, but it still shows the structure, doesn't it? You can even further condense it using the brackets. So CH3 bracket, CH2 bracket times by 6, and then CH3. That still shows the structure of this compound. Now, scientists came up with lazier method, assuming that all the carbons are hydrocarbons and all the carbons are filled with 4 bonds. Someone started being lazy about drawing hydrogens around carbon. So we came up with this skeletal structural formula as well. Now, count the dots or end of the lines. Count the corners and end of the lines. Hope you can count it up to 8. So starting from, say, this end, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 dots there that make 7 bonds in between. It's called skeletal structural formula, which doesn't show hydrogen. It's quicker method, but you may not be understanding that all the carbons are saturated in this point. Of course, you can use double bonds or triple bonds in between if you are to if you're asked to draw that. But yeah, that's a formula that's used to show the same thing, C8H18, but in a different method, but still shows the structure. Okay. Finally, there's what's known as empirical formula. Now, I think we talked about it before as well when you learned about number of atoms in the molecule and counting or how many moles of each or grams of each exist in the molecule. Empirical formula just shows the simplest ratio. For example, in C8H18 octane, well, there are common denominators between 8 and 18. You can divide both of them by 2, can't you? Therefore, the empirical formula for octane is C4H9. It's just showing the simplest ratio of C and H. Empirical formula just shows the ratio. That's all. That's it. Okay. Now, the implication of these different types of formula is that you might get asked to write molecular formula for this compound, or write skeletal formula, a structural formula of this molecule. Okay, so you could be asked that kind of question for any types of organic compounds. All right, so be prepared for that. In the next video, I'll talk about nomenclature, so how systematically compounds are named, as well as how you would draw structure from given names, and vice versa. All right, I'll see you in the next video.